This video will show you how to solve an equation like this one, although it doesn't have to be a polynomial, on your TI-nspire calculator. I chose a polynomial because one of the methods I'm going to use only works with those. This one could have up to 3 solutions based on the way cubics look, which is that they go down on one end and up on the other. It's going to have at least one solution, but it could have 1, 2, or 3. So my first suggestion would be graph it, and I would suggest graphing the left side and the right side separately and looking for an intersection. I know some people prefer to set these equal to 0, and certainly that's a possibility. But the reason I don't recommend it as a first choice is every step you do algebraically is a place you could make some stupid copying mistake with a negative sign or whatever. If you just type what the problem gives you, the left side as one of the functions and the right side as the other, there's not much you can mess up. You can see here that the cubic is almost vertical here. It's possible that there could be some turnaround placed, but once you learn more about cubics, you'll learn there's a point of inflection where it changes from downward concavity to upward concavity, and there's only one of those. We've actually seen everything interesting. On this, my recommendation is to go to Analyze Graph and Intersection. You click to the left, you click to the right, and there is the point you're looking for. Importantly, the point is not the answer. The question says solve the equation. The question does not say find a point. So while this is definitely the intermediate step, the actual answer is x is approximately equal to 0.313. So we're looking for a solution which is a value of x that makes the equation true. Make sure you answer that. If this is something you're justifying on your paper, you should draw a quick sketch, nothing especially fancy, and I didn't get out my tablet to draw on here, but something about as good as what I'm showing you here, which I'm drawing with my finger on a trackpad. Do that, and then I would say like this, and that's x equals 0.313. Like, that's plenty of justification. I've shown what it is I saw. I don't need to make something really fancy. I just need to indicate my solution method. The second method using that same calculator is nsolve, and it should give us the same answer. Nsolve for this same equation, n is for numerical, and that's on a calculator page. So I'll insert a calculator page. And nsolve is menu, algebra, numerical solve. Now, see there's another solve command. I'll get to that in a minute, but for right now, numerical solve is probably a better choice for a couple different reasons. And you just type in the function, like the equation, with an equal sign, which you get here, and at the end it's comma, and then the name of the variable you're solving for. It doesn't have to be x. Whatever it is has to match, though. And wow, there's the answer. The problem with nsolve that you might run across, you'll probably run across at some point, is it doesn't tell you how many answers there are. With the graph, I can see that it looks like there's going to just be one. I could even decide to zoom out some and convince myself that, yeah, that blue graph is never coming back down. With this, I got nothing. I can't tell what that looks like. So the other thing you do is check to the left and to the right. I've arrowed up and got this same command again. And if you do Control equals, and then choose this vertical bar, it stands for when. I can tell it to look when x is greater than, let me put 0.313 a little bit to the right of that. And it says, oh, there's no solution out there. If I do the same thing to the left, so x is less than 0.312, it says also there's no solution there. So unless you're certain how many answers there are, and maybe the problem is phrased in such a way that you know there's only one, unless you're certain, you should check both sides. I do know that because it's cubic, there could be up to 3 solutions, which means if I find a second one, I might need to keep looking in that direction further. But again, the answer that I get out of this is that, and what you had write on my write on my paper is using calculator solver, and then here's my answer. The next possible method to do this, the polynomial root finder, is another just built-in tool that this calculator has. So here's the formula, the equation I want to solve. If you go to algebra again, that's where you'll find the polynomial root finder. It's under polynomial tools, and it's the first one. If you have a CAS, you'll see multiple things here. If you don't, you won't see as many things. But roots of polynomial. It asks you for the degree, and it defaults to 2 minus 3. So I'll just arrow up 1, or I can just type the number 3 in. And then do I want real, or I have a choice for imaginary, complex numbers. Real is good. So I'll say OK. It brings up a dialog box. Now what goes in this dialog box, you'll see it's a sub 3x cubed plus a sub 2x squared plus a sub 1x plus a sub 0 equals 0. They're telling me that the numbers that go in the dialog, a3, a2, a1, a0, are coefficients of x in these various powers. And I need a coefficient for x cubed, a coefficient for x squared, a coefficient for x, a constant, and the 0 needs to be on the other side. So in order to use this, I've got to set my equation equal to 0. It only works in that way. Further, I need to have x cubed, x squared, x in constant terms, and I don't have an x squared term. That's going to look like this. I don't need to write that down necessarily, but I need to remember that that's a 0. So that's what's going to go in here. I'll type a 4 and tab, and a 0 and tab, and 6 and a tab, and -2. And I say OK, and it brings up this command, which you could type if you just knew. And you hit enter, and it finds all the solutions at once. That's a set because there are potentially multiple answers. And for the polynomial root finder, the calculator, even without CAS, will find all the solutions at once. It only does that for polynomials. So again, I get this same answer as before. X is about 0.313. And I would give another this using polynomial solver or something like that to indicate that I've used a command. The last one I'm going to show you is the CAS solve command, and it works fine most of the time. Sometimes it actually is more confusing because if you're watching this, you're probably my student and you're taking an IB math exam. You can't use CAS on that exam, so it wouldn't be available to you then. You start with the same equation as before. It is menu, algebra, and just plain solve. And just like the numerical solve where we type the equation in, we'll type the equation in. So 4x to the third plus 6x equals 2, comma, solve for x. And this time, so there's a slight difference in the way it looks. Up there it just said a number, and down here it says x equals a number. If there's more than one solution, it will give you more than one answer. So let me get one really quick that has more than one answer. There, it gives more than one answer because there's more than one. The problem with this, I mean, it does work really quickly. It does give you all the answers at once. It can give you a big mess. It can be hard to understand the results you get, and that happens really obviously with trig things. So if I solve, let's take a really simple example, tangent of x equals 1/3. I'll just say solve that for x. Should be okay. In radians, that's what I want. What is that? Let me try another one. Solve, not even. Solve cosine of x equals e to the x. Only one equal sign here. Yeah, it gives me more solutions may exist. It starts at -1700, then it skips to -29. There's a bunch of negative answers, and then it's just, wow, it stops at 0. Maybe there's no positive answers, but still, do you really think it skips from -29 to -1700? That's not true. There's infinitely many solutions. Both of these have infinitely many solutions. That n1 is a constant, like telling you periodically. So the period of tangent is pi. This is saying every so often you need to add another pi. In fact, if I did that same equation except without tangent but sine, you get 2 of those because there's a sine is positive in quadrants 1 and 2. So there's a quadrant 1 answer and a quadrant 2 answer, and they're saying repeatedly add things. So the solve command might not be what you want every time. That's why I did the others first.